Hi, guys. So, the assignment that was due this past Sunday was homework number 7. And we had a quiz about it last week, and we're going to have another quiz from it this week. So, I just want to make sure we kind of talk about these again. We talked about them a couple days ago in class, but I didn't put any notes online. So, I just wanted to grab a couple topics that, may or may not show up on your quiz. So, I'm not telling you exactly what's on that quiz, and the quiz is going to be on Canvas this time, just as a heads up. So here we go. Ready? And if you're like, I got this down, then great. There are a lot of people, though, that did not finish homework number 7. So you need to use this time to get ready for this quiz, completing homework 7, and watching this video to help you. So here's the short version. Back in the day when um, you had equations where it was two fractions, like 5/9 equals x over 4, right? One way you could do this is just multiply both sides by 4 to get x by itself, right? Another way you could do this was called cross multiplication. Some people called it the butterfly. So you would do 5 times 4, and you would do 9 times x, and then you would divide both sides by 9, right? No big deal. But that works when you have a fraction equals a fraction. If you have a fraction plus a fraction equals something, it takes a little bit more work because we have to add fractions first. So let's go back and remember adding fractions. So again, 2/3 plus 5/8. Does anything have anything in common? Not really. We need a common denominator. Our new common denominator is going to be, I don't know why I decided to write in this blue area. The new common denominator is going to be 24. If you're like, where'd you get 24? We just multiplied the denominators since they don't have anything in common. So to get that 24, though, I had to multiply 3 by 8. But if I do that on the bottom, I also have to do that to the top of the fraction. So then I would get, whoops, I didn't leave myself enough room. 16 over 24, and 8 times 3 on the bottom over here, and you have to do that to the top as well. So I would get plus 15 over 24. Now I have a new common denominator. I can combine those two terms, whatever is like terms on the top, which 16 and 15 are like terms. So that would just be 31 over 24, right? Okay, so that's a quick reminder on how to add fractions and how to solve it when it's a fraction equals a fraction. We're going to use those two things, put them together here. So first of all, we need to add these two fractions so that we can have one denominator going on. So adding the two fractions. My new denominator is going to be x times x plus 5, right? So this first fraction is missing an x, so I have to multiply it by x. And if I do that to the bottom, I should do that to the top as well. So I'll have 4x for this fraction plus, I do this over here, x times, now I need to multiply by the whole entire binomial x plus 5, this whole denominator. That was over there, right? Multiply the top by x plus 5. So now this is, and then of course we distribute that. 1 times x and 1 times 5 is just x plus 5 over x times x plus 5. And then we can't forget there was this equals 1 over here on the side, so I'm going to leave it. Okay. So now that we've got our common denominator, just a minute ago when we did this, once we got the common denominator, we just add our like terms on the top. Common denominator, add the like terms. That's what we're going to do here. Common denominator, add our like terms on the top. So I have 4x plus 1x, which is 5x. Those are my like terms. And then I still have that plus 5 equals 1. So now you could think of it, now that I've got my a fraction equals a number, I can do the whole butterfly thing where you cross multiply and divide, or Um, I could just think of, well, I gotta get this out of the denominator, so I'm gonna multiply both sides by that. Think of it as a few different ways. And if you're like, well, I don't see another fraction on that side, Miss Flannery. Well, I mean, technically any whole number is over 1. So 1 over 1 is still 1, right? So if we did the cross multiply version, x times x plus 5 times 1 is still x times x plus 5, and it equals 1 times 5x plus 5. Well, what's 1 times 5x plus 5? 5x plus 5, right? And now this doesn't look much better, but let's go ahead and distribute this out here and see what we can do. So we'll have x squared plus 5x equals 5x plus 5. So now we've got a quadratic here, and we had a whole unit on quadratics. And for quadratics, the first thing we usually did was set everything equal to 0 and then go from there. So let's start there, see what we can do. Now, I happen to know that's not going to do as much good, but that's okay. Um, but let's start with that idea. So plus 5x. And now if we go ahead and move, if we subtract 5x plus 5 to the other side, so minus 5x and minus 5. On the right side, that would cancel and we'd have 0. Those would cancel. So now I have x squared minus 5 equals 0. So we have options at this point. You could do quadratic formula. Your A would be 1, your B would be 0, and your C would be -5. You can do that. Since there's no B, there's no linear term, then I'm going to use the square root method. So now I got to move this back over there. I know. X squared equals 5. Take the square root of both sides, and technically you take the positive or the and the negative. So this is x equals plus or minus the square root of 5. If you're going, I have no idea what just happened. Well, let's do another one. Okay. Let's do another one. So this is like number 22. Find all the real solutions. Check your results. I didn't check my results, but we should. Okay, so first I'm going to try and put all this into one fraction. So I'm going to add these fractions together. So this time I have x and x squared. Well, this time, I mean, I could multiply this by x squared and multiply this by x. That would work. But honestly, if I just multiply this one by x, that would be a common denominator then. I would have x squared on both of them, right? I would have x squared as the same denominator, and then I don't have to mess with this other fraction, and I like that idea. So if I multiply the bottom by x, I have to do that to the top. So 1 times x is x equals 4. Now I have a common denominator, and in the numerator, I just have x minus 5. Denominator is x squared. Multiply both sides by x squared. Or butterfly, cross multiply, however you want to think about it. Cross multiply. I have 4x squared. And then again, with quadratics, our first step is always set it equal to 0 and see what we're dealing with. So I'm going to move these guys over here by subtracting x and adding 5. Subtracting x and adding 5. So that's 0. So now I have 4x squared minus x plus 5. Okay, now this time I can't use the square root method because there's an x term in the middle. This little guy right here. I can't use the square root method. And I don't want to factor it because that 4 out front, I feel like factoring would be a pain in the butt. So I'm just going to use a quadratic formula. right? I don't have to use quadratic formula necessarily. I could try factoring it and see if it works, but if I'm going to try something and it might not work, I'm just going to go ahead and use the one that I know will work because I don't want to work too hard. So according to the formula, we have all ax squared plus bx plus c equals 0, and a is not 0, so then we know those. So then the formula says negative b, so negative 1 is positive, plus or minus. So you know what? Let me write that up there. Da, 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 da. Erase, erase. Give myself a little bit more space. X equals negative b plus or minus radical b squared minus 4ac. Cha, 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 cha. All over 2a. Okay, so negative b is negative 1 is a positive, plus or minus, square root. B squared, negative 1 after I square it, minus 4 times whatever a is, which is 4, times whatever c is, which is 5, all over 2 times whatever a is, which is 4. Simplify this. Let's see. I don't have a calculator in my hand. I guess I could pull this guy up just to show you some stuff. Let's do that. Anytime you do a home screen, if you hit second mode, that's the quit. And on the screen, I'm going to hit cancel, clear that out. All right, so I'm going to do parentheses, negative 1 squared minus. Now, do I have to use a calculator? Nope, I could use my head if I wanted to be very careful. I just don't. So, negative 79. Did I miss a negative sign in here somewhere? Let's see. B squared minus 4ac. No, that's definitely this 1 minus a big number. So, I mean, I could have stopped right there when I realized they're only asking for real solutions, and we have to take the square root of a negative number. So, no real solutions. Basically, it's not possible to do this with real numbers. Okay? All right. Next. There's another one. Find all real solutions of the following. I'm going to make this a little bit smaller so I have more space to write. And if I did cross multiply stuff here, right? Cross multiply. Shoo. Well, I would get 0 there, right? So really, I just have x cubed minus 9x equals all that stuff times 0, so 0. If I try and solve this, let's see, let me see if I can hopefully use the product rule. Zero product property is what I meant to say. Let's see, all these have an x in them, so let's factor it. X squared minus 9 equals 0. Oh, now I know real fast that's x plus 3, x minus 3, and I hope you know that too. If I factor x squared minus 9, that's x plus 3, x minus 3. Hopefully you see that too. Not, it's okay. Just you got to practice your difference of squares factoring. And then anything multiplies together and gets 0. That means that one of those things or all of them has to equal 0. So either x is 0, or x plus 3 is 0, or x minus 3 is 0, or all of these above. So we would have -3, +3, and 0. Those are all the real solutions. And it says I better check them. So I'm a little nervous that some of the stuff canceled out. So I am going to go ahead and check them just to double check to make sure I'm not doing something goofy. So if I plug in 0, what happens? I have 0 cubed minus 9 times 0 all over 0 squared plus 2. 0 minus 0 over 2, which, yep, we're 0. So, yep, that's true. X equals -3. Let's try that guy. -3 cubed minus 9 times -3 all over -3 squared plus 2. So that's -27 plus 27 all over 9 plus 2. So 0 over 11, which is 0. Yep, that's what it said it was. Gotta make my phone stop making noises. Shh, stop, stop, phone, stop. And then let's double check 3. 3 cubed minus 9 times 3 over 3 squared plus 2 equals 27 minus, no, I lied. 3 times 3, yeah, that is 27 minus 27 over 9 plus 2, which is 0 as well. So it worked. All right, all three worked. Had to check them. Just double checking. That's how you would do it. Plug in the number and see if it equals what it says over here it's supposed to. It says it was supposed to equal 0, and it did. Ba, 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 da. Okay, so there's, solving rational equations. Okay, that's 3 examples of solving rational equations. 3 examples on inverse proportions and proportionality and all that kind of stuff. So they're telling me k x cubed equals 375 when x is 5. So they're telling me 370. Actually, let me do it here. Let me erase. 375 equals k times 5 cubed. Okay, well, if you're not sure what 5 cubed is, I believe it's 125. Nick's always really fast with those. 5 cubed equals 125. So this is saying 375 equals 125 times k, or k times 125. So to figure out what that equals, we would divide both sides by 125. Bibbity bobbity boop. If you're like, I don't know what that is, then grab a calculator and divide by 125. And you get, whoop, just kidding. I said the wrong thing. 375 divided by 125. 375 divided by 125 is 3. So proportionality is 3. Cool. All right. Let's look at that's number 25. Here's question 24, which is very similar. This time they tell us that when x is 2, so k divided by 2, that y is 3. So multiply both sides by 2, either in your head or on paper. So k equals 6, right? Down here, this is number 25. Find the constant of proportionality k. Oh, that's the exact same question I just did a second ago. I did not mean to put that on there twice. My bad. Get rid of that. All right, that's the general idea with those. If they say inversely, by the way, a while ago we talked about directly. If k varies directly with, or sorry, if I shouldn't have said k, my bad. If y varies directly with x, you're going to set it up with y equals k times x. If they say y varies inversely with, I don't know, x squared or x cubed, or I don't know, w to the fourth, whatever they say, the word inversely means you're going to divide, you're going to do k divided by whatever's next. If they say directly, it's going to be k times whatever is next. So if they had said varies directly with x squared, then we would have an x squared over here. Make sense? So directly means you're going to multiply k times the whatever is over here. Inversely means you're going to divide k divided by whatever is over here. Okay?